How are you guys? In this video we are going to talk about position isomerism, and what we are going to discuss is what is position isomerism, then where or how to observe position isomerism, and we will take some examples. Position isomerism is a kind of structural isomerism. And for structural isomerism, we have already talked that two compounds are structural isomers when they have the same molecular formula. So the molecular formula is same, but there is a difference in their structure. So same molecular formula, different structure. Now for position isomerism, the difference in structure is due to the position. But the position of what? So the position of the functional group present in the compound, or the unsaturation, that is the double bond or triple bond in the compound, or the substituents, at least one of these should be different. But before we actually talk about the position, you must check another important thing between position isomers, and that is the two compounds which we are checking for position isomerism must have same chain length. Only then we check about position isomerism. So let's now talk about some examples of position isomerism. Let's say we have these two compounds. Both of them have an OH group, so they are alcohols. The first thing to check is the molecular formula. For the first compound, we have 3 carbon atoms and 8 hydrogen atoms and 1 oxygen. And in the second compound also, we have 3 carbon atoms. And then we have 3, 3, 6, 1, 7 and 8 hydrogen atoms and 1 oxygen. So the first check that the molecular formulas should be same is done. Okay, then what's the second step? You check the parent chain's length. So in the first compound you have a parent chain of 3 carbon atoms, whereas in the second compound also you have a parent chain of 3 carbon atoms. So the second step is also okay. Now we need to see whether they are position isomers or not. So here we have the OH group as the functional group, and you can see that in the first compound OH is attached to the first carbon atom, whereas in the second compound it is attached to the second carbon atom. So the position of functional group, that is OH atom, is different, and therefore these two compounds are position isomers. And if you decide to write their names, it will become very clear. The first compound is called propane 1-ol, and the second compound is propane 2-ol. So you can see that the position of the functional group is different in both the compounds, and therefore they are position isomers. Easy, right? Let's take another example, and this time we will have position isomerism due to the unsaturation. Quickly look at these two compounds and write their molecular formula. So the first compound is C4H8, right? And the second compound also has the formula C4, and count the hydrogen atoms fast, H8. And then we move on to the second step, that is the length of the parent chain. Both these compounds are straight chain and have 4 carbon atoms each. So both of our criteria match. And now we need to see the position of the unsaturation here. The double bond here is starting at the first carbon atom, whereas in the next compound we have the double bond on the second carbon atom. So the position of double bond this time there is no functional group, we have the double bond. The position of double bond is different, and therefore these two compounds are position isomers. Alright, so let's take a quick look at how substituents are used to decide position isomerism, and we will wind up this video. This time it's your turn. Look at these two compounds and write down their molecular formula. I am going to do it as well, but you must verify after writing it on your own. So the molecular formula is C6H14 in both these compounds. And the chain length, what do you think the chain length is? For both these compounds, the chain length is 5 carbon atoms. So let's look at the position of substituents, and in the first compound, CH3 group, that is the substituent here, is present on the second carbon atom, whereas in the second compound CH3 is present on the third carbon atom, and so we have a difference in position of substituent. Therefore these two compounds are position isomers. So once again, let's quickly take a look at what position isomerism is and the important points. Position isomerism is observed when there is difference in position of the functional group or unsaturation or substituents. And before you check position isomerism, you must check that they have the same molecular formula and same parent chain length. Only then you should check for position isomerism. In the next video, I am going to talk about functional isomerisms. See you in the next video.